doing wrong.
Hey guys, I'm here.
Hello. All right, let's see. Okay, so to the quiz. All right, so number 3, the symbol for the true population proportion is, oh, see, this is the thing.
Plain
So,
P.
Just plain P.
plain P at the bottom. Oh, that's because the sample is your P hat, right?
That is called the point estimate of P.
Yeah, okay. So, oh, I gotta have scrap paper. I don't know what I'm thinking.
Okay, so I'll read 4. This is for question 4 and 5. N is 1,000, P is 0.25, and P hat is 10. The requirements for constructing a confidence interval satisfy. Case.
I get true because for the confidence interval we do n times p hat is greater than 10, and it's greater than or equal to 10.
10.
It's equal to 10, so
Right.
it works.
Yeah.
Did you do the other one where it was the 10 or the P minus 1?
Yes, so it comes out to 90.
Oh, that way. Okay.
Yeah, I got 25 on one and then 90 on the other.
Okay.
When I figured that out. So.
Wait, what did you get on the first one, Becky?
I got 25, which I took.
That means you were using regular p instead of p hat.
Is it 100 times 0.25?
It should be 100 times 0.1.
Oh, 0.1.
When we're talking about confidence intervals, we use regular p for the hypothesis test.
Oh.
Yeah, so it's confusing because it goes back and forth between the two.
Yeah. Hey, thanks for catching that, Ryan.
Yeah, no problem.
Okay.
Definitely want to put that on the note card for the exam.
Yeah, definitely. Okay.
I can't remember if I put that on my notes. I don't think I did. I better go back and put that on there. All right.
Maybe this is why I'm making all of the mistakes I'm making.
Well, it's tiny little things like that. It's hard to keep straight.
Yeah. So on 5, I'm really not sure if the requirement.
So we do the exact same thing, but we use the plain p.
So that's what this one's trying to teach you, is just the difference between it.
Yep. So for this one, I got 25 and 75. Yeah.
I gotta write that down a second. So this one, hypothesis test requirement. Sorry, just a minute.
Let me figure that one out.
P hat. P hat for the hypothesis test, right?
Other way around. P
Oh.
hat for the confidence interval.
And then regular P for
hypothesis
the
test.
hypothesis. So this one, because we got 25 and 75, then we say true.
Yep.
Yeah.
So I got true for both of them.
All right. So a study of first-degree murder trials was conducted in another state. A random sample of 60 people on trial for first-degree murder was taken. Of these, 45 of the defendants were found guilty. With the information for 6 through 8. So let's see. A random sample. So we have N of 60.
So do you divide that by 45?
X of 45. So, yes, so 45 divided by 60.
0.075?
Yeah. 0.75.
Just 0.75.
0.75, yeah. 0.75, yeah. Okay. So this is where I mess up. I can't get my confidence intervals correct on this one. So I have 0.75 plus or minus 1.96, and then square root 0.75, you know, and then 1 minus 75 divided by 6.
Is it a 95% interval?
Well, up at the top they have 95. Yeah, it created 95, so that's 1.96. So is this the one where we're putting it into that different, or are we just figuring it?
I think this is the one we use Excel for.
You can do it either way, but if
Yeah,
you
you can.
Excel
The
it.
Excel
So,
just makes it really easy.
so I got 0.64 and 0.86.
And that's what I got using Excel. Because
And-
if you want to do it without Excel, you have to go and calculate the z-score also, and then you have to plug it back in.
Oh, so that's my problem. I'm not doing the z-score. Okay.
Yeah, so, okay, so for Becky's benefit, let's just walk through one longhand quick.
Yeah. So we got to
Because
calculate the z.
Because I was doing them both ways last night, and I was getting it both ways, so you should be able to do it without the spreadsheet, but it's just way easier with it.
Isn't the z, wait, isn't the z of 1.96? Isn't that what it is? Or am I figuring out something separate?
Well, I can tell you just a minute because it's on my spreadsheet. Z is 0.845.
And that's the, oh.
Well, for this one, we don't have a p, do we?
Our p is 0.75.
That's our p hat.
Oh, but regular p? But I thought we used p hat plus or minus z. But I thought this z was from our confidence interval.
Well, to do your
Well,
standard
we're assuming-
deviation, you have to have regular P. Right?
I thought we were trying to start with longhand by calculating z, which is p hat minus p all over the standard deviation.
Oh,
Which, yeah, you need p for that.
but you don't have to. Use this, so do P hat
Okay.
plus or minus your Z star, which is going to be your 1.96, right? Times P hat times 1 minus P hat,
And isn't that 0.75?
and then, well, we decided that was 0.75 over N, and that whole thing's square root. So if I plug all my numbers in, then I get 0.75 plus or minus 1.96, and then your great big square root symbol. And underneath that, you have 0.75
Oh,
times
okay.
0.25, right? Because I did the math of the 1 minus the 0.75,
Yeah.
divided by N, which is 60.
Yes.
So then if you do that math, you should be 0.75 times 0.25 equals, divided by 60 equals, and then square root, and then times that by 1.96 equals, so I got 0.1. 0.109, we're not going to round, and then 5673, how about that many numbers? So that's my margin of error. So then I'm going to plus and minus that to the 0.75. So if I do 0.75 minus 0.1095673, I get 0.640 for my lower bound,
Okay.
0.75 plus 0.1095673. So 0.859, which would round to 8.86 to my upper bound.
Okay.
And isn't that what we got? Yep,
Yeah.
that's what the computer got too.
Yeah. Okay. No, I get that. I do get that. Okay, thank you.
So, yeah, so maybe you just weren't using the right formula.
Yeah.
Okay.
8. If you increase the sample size from 60 to 80, what do you expect to happen with the width?
So if you increase the sample size,
It would decrease.
yeah,
Yeah.
Because we'd be more confident.
Smaller. Yep.
So number 9. Are you ready to move on?
Yeah.
Okay. To conduct a hypothesis test for one proportion, 2 requirements must be met. Suppose p equals 1/2. What is the smallest n can be, and both requirements still be met?
Okay, so
hypothesis tests, we're using regular p.
yeah, but this one they gave you.
They gave us the p.
Well, but they give you a formula for this one.
Is it NP plus or minus 10? And then N 1 minus P hat plus or minus 10?
Oh, because there's that one that we figure in. There's also one where they give us the margin of error, but they didn't give us a margin of error for this one, did they?
Yeah, this one they just want us
so
to
this is just
solve
that
for n.
other one. So the p hat is 0.5, so
I did my N as 0.5 too.
10 divided by 5. So I get 20 for the one.
And they'll both be 20.
And then, oh yeah, because 1 minus 0.5 is 0.5. So the answer is 20, right?
Right.
You understand that, Becky?
Yeah, I have 20 on my paper. I don't know why I put 40. So, but I do have 20 down here. So one of my tests was 20. So maybe one was 40, but we're taking the smallest. So.
No, because we got 20 for both.
Yeah. So your N, you did 0.2, and your P, 0.5.
No. We're solving for n.
Oh.
So your p hat is 0.5. So you do 10 divided by 0.5.
0.5. Okay.
So that gives you 20.
Okay.
So then to do check your other requirement, you have to do 1 minus 0.5, which conveniently is 0.5.
0.5. Okay.
So you just do 10 divided by 0.5 again. And then you have to take the larger of the two.
All right. Okay, got it.
Okay. All right. So to conduct a hypothesis test for one proportion, 2 requirements must be met. Suppose p is 1/10. What is the smallest n can be and still be met? Isn't this the same question? They just changed the thing.
Yeah, they just changed the number. So I get 100.
Well, isn't it 11? Because, so to check the one, I got 100. But to do the other one, you do 1 minus the 0.1, which is 0.9. So then I do 10 divided by 0.9.
10, yeah.
I get 11. So wouldn't that be the smallest? Oh no, because it has to be 100, so both of them are met. Is that what it is?
Yeah.
I'm
And
thinking of it wrong.
0.9.
Because the other formula is not met until 100, so it has to be 100.
Right.
It's the larger of the two numbers, but it's the smallest one that qualifies. That makes sense.
So you get 100?
Uh-huh.
Yeah.
Is everybody on the same page with that?
Yes. That works for me. You get it, Becky?
Yeah, so why aren't we using 11?
Because if you plug 11 into the first equation, it doesn't satisfy it. You have to have the bigger number to satisfy both of them.
Okay, that makes sense.
It has to be the smallest number that satisfies both.
Both, okay.
Yeah. Which, yeah, happens to be the larger number.
So for the next questions, we're going to use this info. For the water quality study in the reading, about 60% of the macroinvertebrate water quality indicators have historically been associated with good health. Researchers suspect that water quality in the area has decreased. They conduct a hypothesis test using significance level alpha equals 0.05 with the following hypothesis. P either equals 0.6 or it's less than 0.6. Then we get this data. And the question is, the conditions for conducting a hypothesis test are satisfied, true or false?
Oh, let me just pull up this handy applet that figures all this out for me.
Yeah, there we go.
This thing's fabulous. I kind of feel like it's cheating.
Yeah. So X is 38. N is 80.
And we're at a 95, and our P is 0.6. And it's a, say a less than or a two-sided?
I think it's less than. And where do you, so for the null, for the null is where you plug in your P.
Yeah, null is your P. So then straight across from like where you enter your null, it says confidence interval requirements. Those are your two numbers.
Oh,
38
sweet.
and 42. I know, isn't that fabulous?
Yeah, that is awesome.
And then it gives you your P hat, it gives you your standard deviation, and then if you flow down lower, it gives your Z-score and your P, your probability.
Wow.
Yeah, Becky, you totally got to get this.
I know. Okay, so that one, so 11 would be true.
Yes.
And then so 12, the PPAT, did you guys, is it 0.475?
Yep.
Yes.
And then the test statistic is negative 2.282.
So negative 2.28.
Hold this a minute, I got to pull all those up. I didn't write all those down.
Right, negative 2.282. Yeah, this is awesome. It just gives us all of it. We don't have to calculate anything. And it gives us a p-value of 0.011.
I test statistics. Now, but Becky, you don't have the fabulous thing yet. So do you want to walk through them longhand?
I walked through 11 and 12, and I know how to figure.
Okay. The regular Z and the.
Yeah. Or the p-value. Yeah.
Okay. Yeah, and it said when I downloaded that thing that we can use it on maybe it was the video. Anyway, we can use that on test.
Oh, sweet.
Yeah.
Yeah, that'll be nice.
No more trouble with rounding.
Okay. So what is the decision for the test? Do we fail to reject the null or reject the null?
Reject it.
Reject the null.
Oh, Josephine's here.
Hello.
Hi. Good afternoon.
You're just so quiet when you jump on. Maybe we're just noisy.
Okay. Which of the following best summarize the conclusion of this test? If you rejected it, there is sufficient evidence to conclude that water quality in the area has not increased.
It's going to be one of the insufficient.
It's one of the insufficient.
Wait, I thought it would be sufficient.
No, it's sufficient.
Yeah, it's going to be
Yeah.
sufficient.
Reject the null. So there's a sufficient evidence they reject it. That's water quality. So it's either A or
C.
It's
A.
Yeah, sufficient has decreased.
so A. Is that what you said? It's just an A.
Yes, there is a sufficient evidence to conclude that water quality in the area has decreased.
Perfect. Okay, we did it. 100. So, should we talk quick about our colleges?
Yeah.
Find where you guys are.
Yeah, what are we supposed to do? Do we have something to do at the end of today's meeting?
No. we
Well,
have-
Saturday.
Yeah, Saturday is design the study. That's due.
So we wanted to just make sure that we are each using 10 different colleges. And then I think we just need to come up for the verbiage for what we want. And then I'll type it up and send it in for the design the study one.
Right.
Okay, so does anybody want to volunteer to read their list?
Yeah, I got it.
Okay. So it's because Ryan goes first, he gets it. So so if you guys have one he has, cross it off.
Okay.
Okay.
All right. Actually, I'm going to just paste it into the chat box if that's all right with you. Oh, that doesn't really come up that easy. 1, 2. Let's see. Those aren't very readable, are they?
Oh, they popped right up on the top of my screen.
Yeah, can you
But now
pick
they're
up-
gone.
Wait, let me see.
Go to the.
Let's
Can you find them?
Oh, you're testing my ability.
Yes, I can.
Ryan.
You didn't
At
want
the-
us all to type ours in? This may take
I just
hours.
copy and pasted mine from a list I already had made.
Yeah, some of us
had
are
it-
old school.
So if you go top left,
Copy paste.
there you go. Yeah, I can't. Sorry about that. Top left, you swipe your mouse and the sidebar should pop out, and there's going to be a blue chat symbol.
Oh,
If you
there
click
it
on
is.
that, you'll be able to see what I pasted in there.
Yeah, no, I can see it.
Okay.
Let's see. So,
And these ones, I selected these ones as random as I could. I went online and I found a list of all the colleges in the United States, and I did a random number generator on Excel.
oh my word, that's extremely random.
That's why you've never heard of some of these colleges.
Hillsdale,
But if you guys don't do that, that's okay.
McDonald, Princeton, University of Princeton. That one?
You only had one that I had.
Which one?
Princeton.
Yeah. Well, I went first, sorry.
Okay. That's right, Ryan called it. I actually made me a big list in case I had to cross a bunch off.
Nice.
Yeah, I do. I have more than two.
All right, so Josephine, did you get a list?
Yes, I did.
All right. Do you want to tell us what yours are, or you want to be snazzy like Brian and post them?
Yeah, I'll just post them.
Oh, gosh.
I know, Becky, you and me with our note paper.
I know.
Hey, I'm getting an A in this class too, okay?
Good.
Okay, let's see. That one.
She already has the account.
I know, I didn't do the amounts yet.
I have mine too, I just didn't paste that.
Show off.
I didn't put BYU. That's cool.
Okay, I don't have any of those.
I just have one.
All right, Becky, you want to read me the ones you want to use?
Yeah. Okay. Yale,
Nope,
Fairfield University,
nope,
Quinnipiac University, Sacred Heart University,
nope.
Wesleyan University.
Wait, what was the last one?
It's like Wesleyan. I don't know how to pronounce it.
I have that one.
Okay.
Cross that one off.
Cornell,
Yeah, I'll cross that one off.
Washington and Lee University,
All right,
Vanderbilt University,
okay,
Brown,
okay,
Duke,
okay,
Northwestern. I don't think any of it.
okay,
MIT.
okay,
I think these are the expensive ones too.
yeah,
Stanford,
no,
and I put Harvard also. Oh wait. Oh, she has Howard. I did put Harvard.
okay. Okay, we should be good. All right, so what do you guys want me to say on our thing? We just want to say, oh, did we find, I didn't look, did we find a reference for what we want to use as our null hypothesis? Oh, just a minute, I gotta let my dog out. Okay, sorry.
Okay, last time we did say 32,405. Do we still want to use that?
If I would change that one just a little bit, because I went to the actual College Board website and it says 31,231. So it's a little bit less what they say.
Okay. College Board website. Okay, so if I just say something snazzy, like, according to the College Board website, the annual cost of tuition for an undergrad private United States university is $31,231.
Yes.
We propose, whatever, something.
Yeah.
That the annual cost of, say all that again, is different than that.
Yes.
Yeah, good? Everybody okay with that?
I think that sounds good.
Okay, very good.
That sounds like
I'll do it and email it to her.
okay.
So what do we
Alright.
need to have ready for our next meeting then?
I think we just need to collect the data, which we each do on our own, which you two have done already.
Yeah.
Yes.
So I think you're good. I need to go back and find my data.
Okay.
We do that, and then each week we have something different to do.
Yeah, well, step 2 would be collect the data. So,
And then we're going to describe it. So
Yeah.
that might be, yeah. We only have like, what, 4 weeks left of school?
something like
Yeah, is there going to be time to, is it really just one a week?
There's probably maybe more.
I'm just looking at my due soon stuff and it doesn't say anything about when it's due.
It's down at the very bottom. You have to look in the, oh, yeah.
into the folder.
Oh, I have to go actually into the folder.
Yeah,
Okay.
there's a
Okay.
design the study. Okay. Collect the data. That is
So this-
due
On the final overview, it says, collect the data is due Saturday of week 10,
and then describe.
describe the data the next week, and then inference the next week.
Inference and action are due the same week, it says.
Mm-hmm.
And then the last 2 the last week.
Yeah, but then finals week we turn in the PowerPoint and evaluation.
We should just do it all early and get it done. Does everybody agree? So we don't have to
Yeah.
mess with it during finals.
Yeah.
Especially since Ryan volunteered to do our PowerPoint.
Yep. So
Okay.
on
Stuff,
on
right?
this one, Julie,
Yeah.
in that folder there is actually a place for you to upload
Oh, there is?
a document, yeah, instead of emailing.
Yes.
It's under group project at the very bottom.
Yeah, and then you go final project, then design the study, and there's a place you can upload it.
Oh, okay.
You push open, choose file.
Open. Okay. I'm sure I can figure that out. Okay, perfect. I'll do that.
All right, thanks guys. See you
All right.
next Tuesday.
Okay, we'll see you Tuesday.